Awesome, man. Hey, so thanks to everyone again. Some great presentations. I love the the sort of the depth and sort of the way everyone sort of tackled the problem of machine learning over time. The what's the focus areas, what is important, and I mean it's a big part of what I've thought would be relevant for a conversation today, which is to really kind of touch on some of the areas that I run into over time, some of the areas that I thought were important, and some practical examples. So just to kind of give you a little bit of a background who I am, and I think it was rather than kind of drill completely into what my current company is doing, and we'll talk a bit about that as well too. But I just want to give you a bit of a background of where I come from. So I've actually been part of the local tech scene for quite a while. There's a lovely company called Platform Computing that emerged and eventually was bought by IBM up in Markham. Long stint at Oracle with the analytics and helping to build the AI applications team. A company out of Vancouver called Ecoation, sort of delves really nicely with the last presentation where it was really focused on ag tech, and we'll talk a bit more about that. Got a nice run through with the Opus One, which is we did final mile of utilities and renewable energy. So basically turning your rooftop solar and your batteries into virtual power plants and kind of trying to solve the problem of climate change from a different angle. And I'm most recently at a company called Lynk. And what we're doing is really trying to intermediate between people who need knowledge and people who have knowledge and trying to democratize that process. So it's really interesting from a wide variety of applications. And again, I'll touch on and definitely go in a bit deeper. But what I wanted to touch on here is definitely that there's a common theme of how machine learning applications and projects are successful, whether you're a company delivering a product feature, you're tackling a project, or really where my experience really sort of lends into is where you're building or data driven or machine learning driven features. And I think there's a lot of lessons learned and experiences that have gone through this, which you've heard sort of repeated through the prior presentations. But I'd like to kind of give my own take on it and kind of give you a few real world examples as well. So when I think about customer driven AI, and this is as much as we're, when we talked about whether it was Hootsuite or others, but how you decide to socialize your ML project or try to define how this is going to help drive your business, it really helps to really step back from the technical underpinnings of the model, the prediction, the data science, and really put on a product hat. And in reality, I'm a product manager. This is where my background is. So I really take a look at this from a strategy and a feature perspective. But what's really clear here is that if you don't start with a customer value as a clear driver, what you'll end up doing is building something and might not necessarily building the thing that actually delivers value for the customer that you're looking for. This is incredibly important across the game because what you'll also find is that as you go through the life cycle of a proof of concept, of a particular model deployment or particular outcome, how you solve the problem and what you expect often changes. And I think this is the huge lesson learned from the number of projects that I've been involved with is where you started, what you thought you were solving, and what you did in the wild often are very different things. And especially when you start getting customers in less controlled environments or you get different data feeds, you end up finding that if you don't have a clear objective in mind, I mean, you can often lose focus and then actually undermine the application itself. The other key thing is that there's truth in data, which is if your need to train the models based on the data that's going to drive your outcomes. I mean, I've run into this both in agriculture, certainly within the when we were building time series forecasting for Opus One, where we were trying to predict the load on the energy systems and demand. If you don't get the data right, or if they haven't been trained with the expectations of how you're going to use it, and you don't have the ground truth validation, what ends up happening is that the models you deploy just aren't going to work as effectively. It's a big part of the example I'll walk you through, but I think it's also fun as well. The other thing, and I think this is a bit of a broken record, but I mean, as product people, as engineers, as data scientists, we have to be metrics driven, and we have to lean into those metrics on and be accept them as the truth to kind of drive our success. Because whether you're deciding a feature or you're delivering an A/B test or you're trying to decide if it's working or not, it's not just enough to be able to have accuracy or recall or the model performance. You really have to decide, is this actually solving the problem that you were trying to accomplish? And if not, what are you going to do about it? So building machine learning into an overall strategy, into a product framework, becomes critically important, whether you're just delivering a service or actually trying to do something much more strategic. So I thought I'd jump into a real world example of uh, my time sort of spent in one of the ag tech companies at Ecoation. There's this amazing company on the North Shore of Vancouver who are tackling the problems of greenhouse optimization. They've a wonderful platform of robotics mixing imaging sensors, climate, things like temperature, humidity gauges, but also worked with spectroscopy and sort of other attempts to kind of figure out how you can understand the inner workings of plants and to kind of drive the behaviors of them. So if you think of the problem that we were trying to solve here, is that we were really looking to understand how we can improve the performance and success of the growing activities within a greenhouse. Now, greenhouses are freaking huge. They're acres under glass. They're enormous rows, literally just hundreds of thousands of plants at any point in time. And the ability to provide a solution that can give basically microscopic insight into the plant performance and behavior is a true challenge. So what we focused on was the challenge of looking at how the fruit, so tomatoes, peppers, cucumbers, evolve over time, how we could detect them, and then understand the behavior change as they go through their life cycle, and provide guidance to the growers in terms of how well they're producing, how well their particular varietal might be working. What are the other influences, whether it be climate or the conditions of the day? We had to do it at scale and consistent and repeatable, because these are processes that they're looking to, they're delivering to tomatoes on a time scale, not just, seeing if they're, it'd be nice to have some tomatoes at dinner. And the other key thing is that not only are we trying to drive production targets, we're trying to see what else we could do to understand the health of the plants, the effectiveness of pest control measures. So there was a whole sort of collection of things that we were trying to accomplish. So to tackle the problem, it was an image detection problem. We used both YOLO DarkNet and TensorFlow, essentially manual annotation of the images. What is really interesting about the approach that we took is that we use video streams instead of still images. So essentially what this robotics platform was, it was a cart that existed on these rails that drives through the greenhouses, and it takes a continuous feed of images as they go through the greenhouse at a reasonable speed, at more than a meter per second. And these carts are driven by humans, but they often are doing other activities. But as they continue through the process, they're gathering these images, gathering and detecting the state of the plants and then the actual fruit itself. What was challenging as part of this problem was that as you move through space and time, you need to recognize the images themselves, whether they are counted correctly, where they're double counted. So we had to come up with a mechanism for essentially a sliding window of images to ensure that the system itself was tracking it correctly. So understanding the position in space, position in time was critically important. We were able to train the models based on different types of tomatoes, whether they were cherries or tomatoes on the vine. And the system itself actually was built around a combination of both JETS and Xavier sort of edge computing for both model execution, though in truth, we also trained and kind of deployed the models in an AWS cloud as well. So it was kind of a mix of IoT and sort of big iron in the background. So that all seemed well and good, all great, life is good. We've got a product that we're going to go to market with. So of course, the first thing that falls over when you try to do this in the real is that all your assumptions kind of go out the window. And this is a great example, and I mean just a great lesson that anyone has in terms of, as you kind of look at machine learning and look at the things when people talk about the importance of model drift and tracking inference and tracking the behaviors. I mean, this is why it's such an important thing. So the challenge is that when we trained the initial models, it was kind of Vancouver in the summertime with lots of sunshine, with like wide spaced rows and a kind of an example sort of laboratory and sort of example greenhouse. And of course, the first deployments were in France and in Ontario in the winter with like very narrowly spaced rows, and then immediately we started to discover a whole bunch of things about them. So the rows themselves were quite narrow. There wasn't a lot of light. They used artificial light, so trying to detect the color change between the different tomatoes from yellow to green to pink to red to readiness was kind of almost went out the window when you realize they were using LED lights that cast a purple hue across the whole thing. Recognizing that given sort of the angle of the sun, there was times of the day, many times of the day, where it was impossible to get enough lighting to do it. And then as we worked through, we discovered there were tons of other problems that we had to work through. People are erratic. They move up and down with these carts. These carts can go up and down through the canopy. So our angle of attack and sort of a view of the images changed almost dramatically all the time. So what was the solution and kind of what did we do about it? So we really, our focus here was to say, okay, well, we do know that we have something that works. We have models that are accurate when they're given an appropriate set of conditions. So we started to really focus on a confidence score or confidence interval about the model performance, but also the positioning of the cameras and the carts themselves, where we started to trust the data only when they worked within a given range. So if the system was moving at a definable speed, so less than, I think it was 1.2 meters per second, if they were within sort of range, the cameras were within range of the fruit themselves, and the lighting conditions were appropriate. So we had that sort of combination of factors combined with the model performance itself was the sort of the envelope of accuracy that we're then able to use to get confident predictions of and the success of the operations of the system. So the reality was we had to come up with an operating procedure that drove and kind of controlled the operations to provide sort of guidelines. So, I mean, this is also part of any realistic machine learning deployment, is that you're going to learn as you go. I mean, I love the example of sort of water filling in the pivots. I mean, this is exactly the kind of thing you only learn after you've done it, and then you actually have an opinion. So what we ended up having to do was create an operating procedure for the people using the systems to target particular rows at a given time of day, to restrict some of the controls so that they would only sort of move up and down sort of within a certain constraint when they were trying to get accurate data. I mean, the reality is we wanted to be the infinite Tesla of image detection and kind of do everything in every edge case. But the reality is that by constraining the system somewhat, we were able to start getting really good results. The other good learning we came from it was that we probably went in thinking that we could do absolute counts and kind of be able to figure out just how many tomatoes there were in the system. And the reality was that the greenhouses are big, and the time scales are limited. So we started to look at things like baselining rows of tomatoes and looking for variances and looking for change. We looked at rates of change of growth, and that turned out to be much more meaningful. So it was how quickly the tomatoes were maturing versus the actual sort of the actual counts themselves. Though those were actually fairly important. We were able to do, once the model was performing accurately, we were able to make predictions about the tomatoes themselves. We were able to do things like predict harvest dates and do yield estimations. So which is all invaluable to the growers because they're on the hook towards delivering a set of tomatoes to Costco or some supplier. So for them, having insight into the expected dates of the harvest was incredibly important, and then having some sort of yield estimation was also critically important. And this really turned a process that was very inaccurate, where they simply went through and manually kind of tested sort of a certain few square feet of the rows, to something that actually became an integral part of their process. Again, shout out to EcoAtion, amazing company. I know they're growing worldwide, so a huge, interesting company. If you're based in Vancouver, don't shy away from them. They're really an awesome organization. So I'd also like to take up another quick second and kind of talk about another area that I'm working through currently. And I think this is really interesting as well, which is when we talk about some of the challenges around the applying machine learning to more sort of day-to-day tasks. Now at Lynk, which is a company I'm currently with, what we're trying to do is to, for the sort of the catchphrase is democratize access to expertise. But what we're really trying to do is intermediate between people who have knowledge and people who require knowledge. And quite often that knowledge is contained within the people who have built that experience over time. You've heard 3 different speakers tonight, all with a rich set of background and expertise of CI/CD and spectroscopy at scale with satellites. So being able to access that knowledge and understand what it is, and then support a marketplace for the exchange of ideas, is kind of where we're landing at with this company. It grows out of a business that what is called knowledge networks and expert networks, but we're trying to do something a bit more elaborate in terms of tackling the challenges. So what's really interesting about this problem is we're really looking at combining a real mix of data, social data, CRM, LinkedIn, sort of background information, industry knowledge, the sort of the existing sort of behaviors that we have within our system. And what we're trying to do is come up with was, how do we give proof of expertise that not only do you understand the topic, but that your peers provide sort of guidance to that topic, that they can provide feedback, and to further validate whether that expertise is really true or not. So the way this is happening is that through a lot of the techniques that we have within the system we already in place is the ability to have consultations and have Q&A and sort of provide documentation, and each one of these become a corpus of content that we can pull from that both provide guidance to how people's expertise lives, and then also the behaviors of that, and provides the ability for other people to feed back into it. So what's really interesting about it is that this is a very complete and thorough use of NLP techniques in terms of navigating through that, from natural language knowledge graphs to a taxonomy of skill sets of business and industry, classification problems in terms of trying to predict whether you are an expert or not expert, behavioral feedback, sentiment analysis, and then even using some generative techniques in terms of taking that core information and reimagining it in something that is consumable by others. So what we're really trying to do here is to essentially deconstruct the set of information that's associated with an individual. This could be a transcript of a conversation, a Q&A exchange, a feedback loop, and we're seeing some really positive sort of feedback and success on everything from using the standard approaches, TF-IDF, clustering, topic modeling, a real kind of Bayesian classification problem of understanding the meaningful and impactful trending terms and topics within sort of a set of information. We've also built a RDF-driven semantic knowledge graph, which is really interesting from people, skills, industry, but then imbuing it with the behaviors as people interact with the system. So what we're trying to really do here is not just capture the state information of who they are, who you are, exists in the system, but as your activity grows within it, building out those relationships and how those are feeding into it. And probably one of the more interesting things we're doing as well is, we talked about using sort of COTS technologies instead of out of the box techniques. And we're making sort of good use of things like GPT-3 and looking at Lambda and Mom and some of the other techniques that are out there, and seeing some really great success of using some of the generative text and some of the sentiment and conversational AI techniques that are out there to take this wide set of information and represent your knowledge in some sort of meaningful way. So I think this is still relatively new, so I'd love to have some lessons learned and some feedback loops. But what we're finding is that there's our ability to be able to turn and translate this experience of people's in the universe into something that people can meaningfully consume, I think is something that's sort of right within our grasp, and really looking forward to the journey as well. Much like everyone else, we're actively hiring. I've got a couple of PM hires. We're looking at some new data scientists. It's a worldwide organization that sort of has a deep sort of presence in the Far East and Europe as well. So if anyone's interested in a wider conversation, more than happy to have that. And I'm going to stop there.